Today's lesson is simplifying and rewriting trigonometric expressions. So my learning objective for today is I can evaluate trigonometric functions by applying reciprocal identities, ratio identities, and Pythagorean identities. I want to flip over to the back and let's do the warm-up first. We're going to be working with fractions today, so let's just do a quick warm-up, adding, subtracting, multiplying, and dividing fractions. So take a minute and tell me what you get. Okay, so to multiply fractions, it's numerator times numerator and denominator times denominator. 2 times 5 is 10. 4 times 3 is 12. And then I always simplify fractions, so this is 5 over 6. When I divide fractions, I flip and multiply. So this is going to be 2 over 4 times 3 over 5. And then I'm multiplying fractions. 2 times 3 is 6. 4 times 5 is 20. And then I'm going to simplify. So 3 over 10. Okay, when I'm adding fractions, I have to have a common denominator. So I'm going to multiply by 1 of the other denominator. Oops. And 1 is anything divided by itself. So I'm going to multiply the left fraction times 3 over 3 and the right fraction by 4 over 4. So 3 times 2 is 6 over 12. And 5 times 4 is 20 over 12. And after I get a common denominator, then I add the numerators. So 6 times 20 is 26. But the denominator stays the same. So simplifying, I have 13 over 6. Okay, same thing for subtracting denominators. I have to have a common denominator. So I'm going to multiply by 1 in the form of 3 over 3 and 1 in the form of 4 over 4. So this is going to be 6 over 12 minus 20 over 12. 6 minus 20 is negative 14 divided by 12. Watch all the negative signs. So negative 7, 6. Okay, watch. Be careful, careful, careful. Okay, so we're going to do the same thing today, but with trig. So I'm adding, subtracting, multiplying, and dividing. Same process. All right, so let's practice multiplying with trig, and then we'll get to simplifying. So multiplying fractions, numerator times numerator. So sine of x times 1 is sine of x. And cosine of x times cosine of x is cosine squared of x. Okay. So simplifying fractions. So I reduce the numbers, so I am working with the exponents. So anything divided by itself is 1. So I can simplify when I'm multiplying. If you can see right now, everything's multiplied out. So I can rearrange and multiply. So cosine in the numerator divided by cosine in the denominator is 1. So I have sine squared in the numerator and a sine in the denominator. So 1 sine from the denominator simplifies with 1 sine in the numerator. So I'm just left with is sine of x. Okay, when I'm dividing fractions, I'm flipping and multiplying. So if I don't have a denominator, that denominator is 1. So this is going to be sine of x divided by cosine of x, and I'm going to flip and multiply. So 1 over cosine of x. So now I'm multiplying numerator times numerator. I get sine of x, and denominator times denominator. So cosine squared x. Okay, so adding and subtracting. These are a little bit more work with the denominators. So I need to have a common denominator. So let's look. So cosine of x is the common denominator. So I'm going to multiply times cosine over cosine. Anything divided by itself is 1. So now I have a common denominator, so I'm adding my numerators. So 1 plus cosine of x over my denominator, which is cosine of x. Okay. Okay, so when I have two different denominators, I want to multiply each by the other's denominator over itself as 1. So I'm going to multiply 1 over the cosine of x times sine of x minus 1 over sine of x minus 1 plus 1 over sine of x minus 1. I'm going to multiply this one times the first denominator, which is cosine of x over cosine of x. So now I have a common denominator, so I'm multiplying 1 times each of these. So now I'm just adding across. So this is going to be sine of x minus 1 plus cosine of x all over my common denominator of cosine of x times sine of x minus 1. So when I up here as sine of x minus 1, I don't need parentheses because it's really clear what I have. But when I get down to where I have more than one thing in the denominator, then parentheses are appropriate. All right, so let's get to some trig problems. Okay, so my goal is always to simplify down into a single trig term or a number, because I'm trying to factor and solve for the angle. That's where we're shooting for, and we're getting there. Okay, so I'm starting out with sine of alpha plus cotangent of alpha times cosine of alpha. So I'm going to start by rewriting tangent in terms of, or cotangent in terms of sine and cosine. So this is going to be sine of alpha plus cotangent is cosine of alpha over sine of alpha times cosine of alpha. So I want a common denominator. So my denominator is sine of alpha. So I'm going to multiply times sine of alpha over sine of alpha. So now I have numerator times numerator. So I have sine squared alpha plus cosine squared alpha all over my common denominator of sine of alpha. Well, I remember the Pythagorean. identity is sine squared plus cosine squared equals 1. So I'm going to substitute the numerator with 1 divided by sine of alpha. And then when we write our single trig term, we write it so I don't have a denominator. So I'm going to rewrite sine as cosecant of alpha. So I write whatever my final trig term is, where I just have a numerator, or my denominator is 1, I could say. All right, let's try the same thing with number 2. So I'm going to start by rewriting cotangent again. So this is cosecant of y minus cosecant of y times cosine of y divided by sine of y. So I know I can I'm sorry, and I want to rewrite cosecant as 1 over sine of y. So I'm going to rewrite this one too. So the 1 over sine of y. And by doing that, then I have the same denominator. So now I'm working with the numerator. So this is going to be 1 minus cosine squared y divided by the sine of y. So 1 minus cosine squared from the Pythagorean identities is sine squared of y divided by sine of y. And then I can simplify. So 1 sine from the denominator with 1 sine in the numerator. So I'm left with is just sine of y. Okay, so these use a pencil. I would write on lined paper. And you might even want to do spaces between lines, because when you're doing erasing, it makes a big difference. You don't have to rewrite everything all the time. Just rewrite till you see what you need. Okay, rewrite each expression so that it's not in a fractional form. So I want to multiply by the conjugate, okay? So multiply by the conjugate. We did this at the beginning of the year when we were talking about complex numbers. And the purpose of that was to eliminate the 2 middle terms. So I could write my complex number in standard form. Okay, so I want the conjugate of the denominator. So if I'm 1 plus sine of x, the conjugate is 1 minus sine of x. Okay, so I am multiplying times 1. Anytime I multiply times 1, I don't change my equation. So in my numerator now, I have 1 minus the sine of x. And then if I really look at the denominator, this becomes the difference of perfect squares, right? So instead of multiplying it out and seeing the 2 middle terms cancel, I'm going to rewrite to 1 minus sine squared of x. Okay, so I really need to recognize a squared minus b squared equals a plus b times a minus b. And I want to recognize going this way and factoring. Okay, so next I know 1 minus sine squared is cosine squared. So I'm going to substitute 1 minus sine of x over cosine squared of x. And now I'm going to separate my fractions. So I'm going to rewrite this as 1 over cosine squared of x minus sine of x over cosine squared of x. And I can rewrite this as secant squared of x minus sine of x divided by cosine. I'm going to separate these. So I have cosine of x and cosine of x. Okay. And then I'm going to rewrite these two terms so that they're in the numerator. So I'm left with is secant squared of x minus sine over cosine is tangent of x, and 1 over cosine is secant of x. Okay, so my goal is, for this, I'm rewriting so I'm not in fractional form. I'm not trying to get down to a single term. And when I want to write it not in fractional form, that means everything's in the numerator. All right, so let's try one more like that. Okay, so I'm trying to go from a fraction to not a fraction. So I'm going to do that by multiplying by the conjugate. So if I have 1 minus sine of x, the conjugate is 1 plus sine of x. And I multiply that in the form of 1. So anything divided by itself is 1. So now I have cosine squared of x times 1 plus sine of x. And in my denominator, so I'm recognizing that I have that a plus b times a minus b. So I'm going to switch this to a squared minus b squared. If I want, I can multiply out and see the two middle terms cancel, or I can go right to 1 minus sine squared of x. And I know 1 minus sine squared of x is cosine squared. So I have cosine squared of x, 1 plus sine of x, and I'm substituting 1 minus sine squared with cosine squared of x from the Pythagorean identities. And then all of this is multiplied out. So anything divided by itself is 1. So I can simplify when I'm multiplying out, not when I'm adding or subtracting. So I'm left with is 1 plus sine of x. Okay. An alternate way we could do this is that's all right. I'm going to just show one way. All right. Substitution. When we use substitution to write a trig form, so I'm going to substitute x equals 5 times the sine of theta. So this is kind of some setup for something we're going to do in the next unit. So I have where I have x, I'm going to substitute 5 times the sine of theta, and that is squared. So when the squaring's on the outside, it applies to both terms. So this is going to be 25 minus 25 sine squared theta. So I'm going to factor out a 25 here. So this is going to be 1 minus sine squared of theta. And then I'm going to use the Pythagorean identity and substitute 1 minus sine squared with cosine squared of theta. And then these are two perfect squares. So this is going to be, right, this is 5 times 5 and cosine times cosine, right? So I can take these out as 5 times the cosine of theta. Okay, that's it.